Okay, we are going to go through the definitions and notes for 2-1. We're going to start with some definitions. First important definition is a transversal. It is a line which intersects two or more coplanar lines. And when we get to the picture, it will be line R. Basically, it's going to be the one that cuts across other ones. Oh, I can't do that. Okay. Corresponding angles. They correspond. They're in the same position relative to the transversal and the intersecting lines. So angles in the same side of the transversal and on the same side of the intersecting lines. Alternate interior angles are angles on opposite sides of the transversal but inside the intersecting lines. I'll come back through the examples in a minute. Alternate exterior angles are angles on opposite sides of the transversal and outside the intersecting lines. And same side interior angles are angles on the same side of the transversal and inside the intersecting lines. So let's go back and look at the examples. As you can see here, line R in our picture is our transversal. It's the one that cuts across. Now, corresponding angles are on the same side of the transversal, same side of the red one, like 7 and 5, and on the same side of the intersecting lines. Then another set of corresponding would be 1 and 3, because they correspond relative to the transversal and the intersecting lines. Now, alternate interior are on opposite sides of the transversal and inside the intersecting lines. So 7 and 3 and 2 and 6 are alternate interior angles. Alternate exterior are going to be outside the intersecting lines and on opposite sides of the transversal, like 1 and 5 and 8 and 4. And lastly, same side interior are going to be on the same side of the transversal and inside the parallel, or inside the intersecting lines. So 7 and 6 and 2 and 3. Those are very important definitions and terms we're going to use a lot. Now, these are review concepts. Remember, a linear pair forms a straight angle that adds to 180. So for example, 1 and 2, 4 and 5. And I just want to remind those are not going away. Super important ideas. Vertical angles are our opposite angles that make our V. So 1 and 7, 4 and 6. And remember, they are equal. Now, some examples. What kind of angles are 1 and 5, and what is the transversal? It actually works better to look at the transversal first. If I look at where 1 and 5 are, I can see that the line M is the transversal, and in relation to line M and line P and T, these two are corresponding angles. They sit in the similar position relative to those markers. If I look at angles 3 and 12, here's 3 and here's 12, it's easy to see that this is my transversal, and in relation to the intersecting lines in that transversal, 3 and 12 are alternate exterior angles. When I look at 10 and 4, here's 10 and here's 4, that transversal jumps out at me again. And in relation to the transversal and the intersecting lines, 10 and 4 are same side interior. Now there are lots of pairs of other angle relationships going on. And so if we look for a pair of same side interior angles, I might use T as my transversal. So if T is the transversal, then 10 and 5 are same side interior. And there are lots of other examples. If we look at a few more examples, one pair of alternate exterior, let's let M be our transversal, alternate sides of the transversal, and we want exterior, so outside the parallel lines. So if M is our transversal, then angle 1 and angle 7 are alternate exterior. If we let P be our transversal, alternate interior angles, one example would be 11 and 4. And again, there's other examples. These are just a few. A pair of corresponding, let's go back and use T as our transversal. And if we're looking for corresponding, that means they sit in the same position below and to the right, below and to the right. So if T is my transversal, then angle 9 and angle 7 are corresponding. Now, if we think about knowing angle measurements, if angle 7 is 30 degrees, we would have vertical angles to know that 5 is 30 degrees, and then we could use linear pair to know that 6 is 150, and vertical angles or linear pair to know that 8 is 150. In the same manner, if I know that angle 3 is 2x minus 4, then I know that angle 1 is also 2x minus 4, and I would find the linear pair by taking 180 minus 2x minus 4. But watch how I have this as a quantity because 2x minus 4 is acting like a single number. Now, these are super important. This is where geometry starts to get interesting. If you know two lines are parallel, you get certain angle relationships, and I'm always going to talk about knowing and getting. So the first one is parallel implies AIA, alternate interior angles are equal. If two parallel lines are cut by a transversal, then the alternate interior angles are equal. If you know the lines are parallel, you get that the alternate interior angles are equal. An alternate interior would be 4 and 6, 5 and 3, because in this case, our transversal is T. Alternate interior or alternate exterior angles are equal. If I know the lines are parallel, I get that alternate exterior angles are equal. Alternate exterior would be 1 and 7, 2 and 8. Corresponding angles are equal, and there are 4 sets of corresponding angles. If I know parallel, I get that the angles are corresponding, the corresponding angles are equal. These are going to be proof steps. So 1 and 5 are going to be equal. 4 and 8 will be equal. 2 and 6 are equal, and 3 and 7 are equal. And then our last theorem is same side supplementary. Now this one is different. If parallel lines are cut by a transversal, then the same side interior angles are supplementary. They add to 180. So in this case, 4 and 5 are going to add up to 180, and 3 and 6 are going to add up to 180. So given the picture, if angle 4 is 98, find the remaining measures. And what you can see is vertical angles, 2 is 98. Now go through, I know these are parallel, 4 and 8 are corresponding, so this is 98. 8 and 6 are vertical, or 6 and 2 are corresponding. Then I'm going to use my linear pair or supplementary to find the rest of my angles. And that means that this is 2, 82, 82, 82, and 82. So it makes solving a picture very easy. So in summary, angle 2 is the same as angle 4, which is the same as angle 8, which is the same as angle 6, which is 98. And angle 1 is equal to angle 3, is equal to angle 5, is equal to angle 7, and they equal 82. Now let's look at the next example. If 2 equals 4x plus 7, and 8 is 5x minus 13, find x. Well, if I know they're parallel, I have to look at what is the relationship. Are they equal or do they add to 180? And 8 and 2 are alternate exterior. So they are equal. So 4x plus 7 is equal to 5x minus 13. Subtract 4x from both sides. Add 13 to both sides. And there is x. In looking at the next example, if 4 is 58 and 5 is 3y minus 2, what kind of angles are 4 and 5? Well, they're on the same side of the transversal and they are on the inside of the parallel lines. And so these are same side interior. And if the lines are parallel, they are supplementary. So 58 plus 3y minus 2 equals 180. Combine like terms, 3y plus 56 equals 180. Subtract 56 from both sides. 24, y is 8.